Okay, this is a review for number sets and Venn diagrams. Um, let's go through the different number sets that we learned. The first one is n, which is the natural number set. Um, the natural number set are just numbers that you know as a young child. So 0, 1, 2, 3. You know the whole numbers. Counting numbers, maybe you also know 0. IB considers 0 a natural number also. Okay, so natural numbers are 0, 1, 2, 3, the easiest number set. Okay, Z is the natural number set plus the negative wholes. So that would be the set of integers, which are all the whole numbers, including negatives, positives, and 0. So it's written as dot dot dot, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, etc. Okay. Now let's look at the rationals and the irrationals. The difference between a rational number and an irrational number is a rational number can be written as a fraction and an irrational cannot. Now, how do you know if a decimal can be written as a fraction or not? If the decimal ends, if it terminates just like that, then it can be written as a fraction. If the decimal repeats forever, then it can also be written as a fraction. If it's none of those two cases, it cannot be written as a fraction. What's different than those two cases? Well, like pi. Pi is a very long decimal, and it never repeats any patterns. Okay? And that is also true for any square roots. So square root of 2, square root of 3, square root of 5, square root of 6, square root of 7. Any square roots that are not perfect squares are irrational. They go on forever without repeating patterns. Square roots that are perfect squares, of course, are whole numbers. Square root of 4 equals 2, for example. What's another number that's an irrational that you know? E. If you remember E from natural logs. Okay? Also goes on forever. Okay, so the irrationals cannot be written as fractions. The rationals can be written as fractions. Okay. When you write a rational as a fraction, it needs to be written as a whole number over a whole number. So m and n are both integers, and n, of course, is not 0. If it was 0, then it would cause the whole thing to go to infinity. R is a real number. Real numbers are pretty much all the numbers that we talk about in this class. Okay. What is not a real number are numbers that have square root of negative 1 as part of the component for the number. Now we're going to do a Venn diagram example. Okay. So in this case, I drew a universe of real numbers. Okay. And I have two sets. One is the whole number set, and the other one is the negative number set. Okay. So let's see where each of these numbers that I put at the top go in this Venn diagram. So let's see. Negative 3 over 2. Well, is that a negative number? Yes, it is. Is that a whole number? No, it's not. So it is a negative number, so I need to put it inside the negative number circle. But it's not a whole number, so I cannot put it in the whole number circle. So that means it cannot go in this middle section, which is in both, right? So I need to put it out here. Okay. Negative 4 over 2. Negative 4 over 2 is actually a negative 2, right? And so even though it's written in a form that does not look like a whole number, if you divide it out, it is a whole number. And it is a negative number. So that would go in both, right? It's a whole number and it's a negative number, so we'll put it here, negative 2. Or we could write it just as it said there, which would be negative 4 over 2. Okay. Now, negative square root of 3, is that a whole number? No, it's an irrational number also. It's not even a rational number. but we don't have a rational number set here. All we have is whole numbers, negative numbers. It's not a whole number. It's a negative number, so we would put it in the negative number set, but not in the whole number set. Now we have square root of 3. Now square root of 3 is not a negative number. It's not a whole number, so the only place it can go is outside, right? And last of all, we have square root of 3 minus square root of 3. Now that is just 0, right? Because if you subtract a number from itself, it's just 0. So maybe it looks like an irrational number, but it's actually 0. 0 is a whole number. Is it a negative number? No, it's not. So we'll put that representation out here. Okay. So that's it for this section. Just be careful because a lot of the examples have things like, instead of whole numbers, maybe they'll put z. Okay, and sometimes they might put something that is not one of the number sets, traditional number sets that we learned.